matrix minus A, that is most in the diagonal, main diagonal, we have most ones, and here we have the inputs of each activity. We should calculate also S, the unitary emissions, instead the total emissions that are downloaded directly by EXIOBASE, and we divide F by X. I changed the unit to kilograms by multiplying by 10, by 1000, but it's not necessary to do that. Here, we have to create the index of the matrix to create the data package. So we create a Ning that is a list of numbers from 0 to the size of our matrix, that in this case for hybrid unit EXIOBASE is 700, 708,000 7,882. And we also create a Ning for CO2 for the emission that we want to use. These numbers have to be higher than this, have to be different of the Nings for activities, and I choose that numbers, but even choosing any different number over n is possible to do that. And emissions are, in my case, I only the greenhouse gases emissions, but you can use another type of emissions. To create the data package, we need three inputs: the technosphere matrix, the biosphere matrix, and the method that we want to use. And we are going to create by the command create data package. The technosphere matrix corresponds to identity matrix minus A. And here we have the values, and we have to flatten the matrix because we need a sparse matrix. And flatten is to sparse the matrix and creating a single row with all data. For the index is the same. We have to create a row with the location of the matrix 1 1 1 2 1 3. So here with iter tools we can create that combination of 1 2 1 1 1 2 1 3, and is the same size than the technosphere matrix. For the biosphere data, the information is in S, and I choose only the first row because I need only the greenhouse gases emissions information, but you can use another additional emission. We do the same for the index because we need a sparse matrix. We use the same for biosphere data, and we create here, we can see the locations of the elements of B data. The first one is in row 2001, 0, 2001, 2000, no, 20,001, 20,002. This is important to change here the number for emissions and not use for activities. And the method, I used to work with environmental footprint version 3.1, but you can use the method that you want. Maybe if EPC is better for climate change, whatever you want. Here you put by hand the numbers, the coefficient factors to convert to CO2 emissions equivalent. And now we can create a data package. Here is to start the data package. We create that, and later we add information. First, we add the technosphere matrix, and we add index with index and data. The same for biosphere matrix, and the same for characterization matrix that represents the method that we are going to use to create, to convert CO2, methane, and nitrous monoxide to CO2 equivalent emissions. We finish the data package, and now we can use it. We can use the command LCA and define our demand. That in my case, I choose the activity of copper production in China, but I'm used to work with critical raw materials, but you can use what activity that you want. The problem of that is that you have to know where is located the activity in which row. In China, is the exam is located here, but this is the main disadvantage of the package, that you have to know where it's located and put by hand the coefficient factors. Now the database, we have to introduce also the technosphere matrix, biosphere data, and biosphere reference to connect with biosphere 3. The command that we are going to use are importers and tidy tables from a bonsai project, and now we can create the database. First, we are going to start with the database, and the technosphere matrix have the numeric values of the identity matrix minus A, and the rows are the countries and the activities. We create a unified value of country and activity to have only one row instead two. Um, the same for biosphere matrix that we are going to use as emission. Here I'm going to use all data from S because it's easier to import all data, instead only greenhouse gases emissions. For us, also we create a single row to explain what are to have in the same place the substance and the compartment. Here we can see how it says created. Here we have the emissions and compartment and the values for each activity for every country. And now we can create a database. Firstly, we are going to introduce, create the index of the database. Product metadata are the product index, are the location, countries, and the units. Biosphere are the name of the substance, the unit, and the compartment. And finally, we can create the biosphere. Here we can see the biosphere data, that is the activity and the conditions, the characteristic of it. Here is just to prove that the database is working and is well created and Biosphere is well installed. And now we can have to connect the Biosphere, our names, with codes from EcoInvent or Biosphere 3. Here is to connect these two cells, are to connect our names, and here we can see our names with the codes from Biosphere 3. It is necessary to create later the database. And here we create the database. Here is for not installed if it is installed yet. And here we use tidy tables to um, tidy all matrix. And here for creating the database with the name and with the information. And here we can use, we called our database like test, the location names, the method that we want to use. The main advantage of database is that we can choose any method and maybe of climate change, of acidification, because we add a lot of substance informations. This is for checking that we had not invented the method at it in Brightway. And here we choose the activity. Here is also an advantage for data package because we don't have to know where is located the activity. We just say copper products in China, and we can name any activity from EcoInvent. And now we use the LCA, and we have the same value than in the last cases for the data package. Here, there is a quick check to confirm that if we multiply the matrix by hand, we have the same value for climate change. If we multiply L by S, we should obtain the total impact. And if we use the same coefficient factors, we can obtain the same value of climate change for our activity, that is copper production in China, but is you can use whatever you want. And the conclusion of this work is that this is possible to create a database with EXIOBASE and combining with other databases with time efficient, that if we have created database of EXIOBASE, it's possible to combine with EcoInvent or with other additional databases calling different activities. And the second step of this study is to create to adapt this database to activity browser because nowadays it doesn't run in activity browser. I don't know why. And it's to be easier to combine EEMRIO method with conventional technologies. Thank you for your attention. Here is my email if you have some question.
Thank you.
If
Sorry, thank you very much, Maria. Are there any? There's one question. Oh no, there's other stuff in the chat. But are there questions in the room? Yes.
Hi, thanks for the presentation. It's impressive stuff. Could you comment on which steps you found the most slow or frustrating when you were going through this, and where you might want additional sort of utilities or help to speed things up to do this kind of thing in future?
sorry, could you repeat? I didn't hear the question well.
So, which were the slowest and most frustrating steps that you encountered when you were trying to do this?
Uh, I think that the most slow is to create the database because you need a computer that run. Sometimes the computer is out of memory and close the project, so you need a good computer to run the code with all data because EXIOBASE database are very huge. So um, is the I think is the worst part because they are too much information. I say that there is around 90,000 rows. 90,000 per 90,000 is around 81 million of data, so it's very huge data.
Great. There's one more question in the room. Sorry.
Hello, thanks for the presentation. I'm glad somebody is using actually the IO importer. The problem with the activity browser might be that the IO importer uses the IO table backend, and maybe the activity browser is only working with things in the SQL backend, but I guess it could be converted to, it could be converted to the SQL backend from the input-output backend. It's just that it might be because there's a lot of, like the technosphere is quite dense, might be a bit sluggish and slow in the activity, but it's something to be tested.
Thank you very much for your support, for your idea for trying to adapt to activity browsing. Thank you very much.
Is there any other question? Otherwise, I thank you again, Maria, for your presentation.
Thank you very much for you.
And then our next presentation is on how to import EXIOBASE to Brightway 2.5 by Ning An. She has already been with us for one presentation, so welcome to the second. And she has a master's degree in computer science, specializing in machine learning. And she's now working as a research assistant in Life Cycle Sustainability Group at Aalborg University. And there she focuses on applying AI to the LCA field.
Yes. Hello, everyone. Good morning. It's me again. I'm Ning from Aalborg University, and this time I'm going to present a library. It's called Bamboo. It can help importing EXIOBASE into Brightway with also uncertainty modeling. So how the story begin? So first we consider to compare the uncertainty of input-output and process-based LCA inventories. But then we have some challenges. So we know that Excel-based data is very large and difficult to handle in the LCA software. And also we know that the Brightway cannot direct import the EXIOBASE. They used to have a library for that, but then it broke. There was also another work from Miguel. He presents IO importer, but this is like before his importer comes out. And the last challenge is that the EXIOBASE don't include any uncertainty informations. So we have two questions: how to import EXIOBASE efficiently into Brightway, and how to perform uncertainty analysis easily. So here I bring the solution. It's a library that's more generalized for also other users who use the Excel-based database. So it's based on the Brightway 2.5, and it used the data package feature of Brightway to handle the Excel-based and foreground system data. And the last point is it allows use the native Brightway to run the LCA simulation. the features about this library is mainly two. First, we have the functions to import the input-output tables, especially EXIOBASE. And then we have different strategies to handling the uncertainty information importing. So first, we have the uniformly sampling, which means that we sample the same uncertainty type and value for all the activities. And then we have the column-wise strategy, which can apply different uncertainty types and values per activity. For example, if we have two activities like the agriculture sector and energy sector, so you can sample different type and value, the uncertainty. You can sample for the agriculture sector, you can sample with uncertainty type 3, which, as I remember, I think is the normal distribution. And then the value, for example, is 0.1. And then the energy sector, you can sample the type is 2, which is the log normal uncertainty, and the value, for example, is 0.2. And also the last strategy is item-wise. It can apply different uncertainty types and values to each individual exchanges. So this is for the activity, and this is for each exchange. So here is the workflow for this library. So the first part here is your file that you need to prepare yourself. You have the foreground system and background system data files. So in EXIOBASE, the data file is a TXT file, and for the foreground, you need to prepare the CSV file. And then here, the library will do the job. So first, it converts the foreground system and background system into a matrix. It is a NumPy. It is NumPy arrays, and then it will use the information, the uncertainty information you provide, to build the uncertainty NumPy arrays. And this is the two core parts for the data package. And then after you have those arrays, you can create the data package, and then you can run the simulation using the function from the Brightway 2.0 directly from the data package. So here is how to prepare the input file. For the background database, it's super easy because it's just there. And for the EXIOBASE, it's ATXT and STXT. And I think you have the knowledge previously what the EXIOBASE is, as our last presenter present. And then you have the foreground system file. So for this file, you need to prepare yourself so that you can use the library. It's basically it's not that complex. It's 3 columns. So first you provide the name of the activity, and then the name of the exchange, and then the type of the exchange, and then the exchange amount. So this is the situation if you want to run the static LCA. And if you want to do the uncertainty analysis using this library, you need to add 3 more columns for your foreground system. So first, you need to know which kind of uncertainty analysis you want to apply. There is the library support 4 different, is corresponding to the design of the Brightway. So 0 is no uncertainty, 0 and 1 is no uncertainty, and 2 is a log normal. 3 is, I don't remember quite clearly, but we can check it out on the website. And then here is the GSD. So for the normal distribution, it's just the uncertainty value. For the log normal uncertainty distribution, it is GSD is a geometric standard deviation. And then the exchange negative is when you have the negative values for the exchange, and then you need to set the exchange activity true to enable the log normal uncertainty calculation. And like we know, except the technosphere biosphere, we also have the characterization factor. So here is a file that you can prepare the characterization factor. It's also super easy. So you have the activity name from the EXIOBASE and also activity name from the eco event. And here is the Brightway code and this characterization factor numbers. So there's actually two options. If you don't have the characterization factor, you want to search it from the Brightway, then you need to provide the code. So there's function in the library can help you find the actual numbers. But if you have the CF numbers already, you can just add in the document. Yes, so there for the data packages, there are two main parts, which is the matrix, the biosphere, technosphere, biosphere, and characterization factor, and also the uncertainty arrays. So if you provide these two type of information, then you can create the data package. So for the matrix, here is a figure to show the idea how the matrix looks like. This is the background for technosphere, and this is the background for the biosphere. So here is your foreground system, and here is the exchange from foreground between foreground system and background system. Here is the exchange between the biosphere and the foreground system. Here is just all zeros, like to make the matrix complete. And here is the idea of the uncertainty arrays. So for the uniformly strategy, it is super easy. You just assign the type and value directly. For the non-uniformly strategy, which you add the uncertainty column-wise and item-wise, here in the library, it designs a metadata dictionary. It can, so first, yeah, this is the how I do the work. So you have the uncertainty information, and then the library will load the information into the metadata, and then I will create the uncertainty arrays based on the metadata. So this is what it looks like. It's a dictionary, and this is the index, activity name, type, uncertainty amount. This is for the column-wise strategy. And this is the final uncertainty arrays output. And when you perform the LCA, is super easy. It's just like how you use the Brightway. So you code bc.lca to run the LCA simulation. And the three parameters, if you run the uncertainty analysis, the three parameters you need to provide. The first is a functional unit. And then here is a data package we create in previous step. And then you just set the use distributions to true to enable the uncertainty analysis. And to use this library, it's also very simple and user-friendly. It is available on the Hyhyve. So you just pip install Bamboo LCA in the terminal, and then you have the library. So I have some notebooks. Yes. Yes. This is the example to use the library to run zoom in. Do the RCA using the column-wise uncertainty strategy. 5 steps: prepare the input files, import the product system, import uncertainty information, create state package, run the simulation. Here, it's just create the project and show the databases. I have some databases myself locally. And here is importing the library. And then you have some constants value you need to prepare. This is EXIOBASE background database file, and this is a foreground database file. Like we expand, we also have the example in the library so that you know how to create those files and where you should put. And here is the characterization factor file, and here you define the method you want to use. The example is using the IPCC 2013. And here and next you define the biosphere emissions. I have some example as example. And then we import the background system. So you create the instance, and then here, these 2 steps, you get the data. And then you call the function from the library, build tech matrix to create a technosphere matrix. And you call the build bio matrix to create a biosphere matrix. You call the build CF matrix to create a CF matrix. Yeah, there's different strategy. By default, it will use the CF numbers you provide in the CSV file. And the next step, we import the foreground system. So first, you call the function get bg activities. You get all the activity from the background database and get fg activities to get all the activities from the foreground system, and then you just add them together to get all the activities from your product system. Yes. And here you call the function from library get the fg date frame to get the date. Wait a second. To get the basic matrix, and then this function is to combine the foreground database and the background database. Yeah, this is also a function to combine those 2 databases. So this is in matrix format, like we show in the picture. Okay. And here you have a function to prepare DP matrix to create the matrix in a format that can acceptable to the data package and Brightway. And then you load the uncertainty information into the metadata. Here how it looks like. And here you call the function add non-uniformly uncertainty to create the uncertainty arrays, and then create the data package, and then set the functional units, and then perform the LCA. So I will just run everything together. You can also check this notebook in the GitHub. we don't have too much time left. So here you can see the OC score. Yes, that's it. Thank you for your attention.
Thank you very much, Ning. That was really interesting. And I'm sure there are some questions or comments for Ning. Yeah, I see 2 hands.
Very nice work. For me, it's just more of a
Thank you.
suggestion.
Yeah.
It would be nice if we could then access EXIOBASE as regular database instead of, reading these raw text files and shaping a data package and feeding that into Brightway to Calc. That's maybe efficient, but then it's also convenient to be able to query a database, search for data sets, read metadata. I think this could be a potential improvement
that's
in the
a
future.
really good point. Because this library is mainly focusing on perform the uncertainty analysis. So we manipulate the data set. We don't have much metadata in consider, and this is also the next step we are going to work on. So thank you for the question, suggestion. Yes.
Hi. Yeah, thanks for the presentation. It seems like really nice work. I had a question conceptually. So the uncertainty data you put in is on the foreground. Do I understand it correctly, or can you also provide uncertainty data for the background if you want, if you have? And maybe a second question: the foreground still comprises EXIOBASE industries, right, or product categories, or can they also be? There's no match in between an eco event and the eco event in the foreground and EXIOBASE in the background.
Okay, so for the first question, so you have the uncertainty file to include all the uncertainty informations, no matter is foreground or background. You just have the correct name. So it's first the exchange and then the uncertainty information. So yes, you can provide the uncertainty information either foreground or background. And then the second question, I not hear it very clearly. Can you repeat?
The second question was, what does the foreground look like? Is there only like, is it comprised of only EXIOBASE product sectors or industry sectors, or can you have a different foreground from a different database like EcoEvent?
The foreground is from the user, so you create your own foreground. I don't define like which database is it from. You just have the exchange there. Yes.
A quick question, like, thanks for the presentation, and indeed, this allows to use uncertainty in the background, that in this case is EXIOBASE, if I understand correctly. But how do you quantify? Do you have ideas on how to quantify the uncertainty on the on EXIOBASE?
So the EXIOBASE don't have the uncertainty information, and this library only provides the service that's to help you import your uncertainty information. So it depends on your experiment, what kind of uncertainty information you need. Then you create your own uncertainty files. So it's kind of import uncertainty. Yes.
So we have to continue in the sake of time. Thanks a lot.
Thank you.
Sorry for the next speaker. You can install yourself, but